Okay, so we've spoken about what a dictionary is in Python, and we said a dictionary is a set of items, and each item is a key value pair. And then we discussed a whole bunch of methods that are available, 11 methods are available, and there were some methods that we have actually seen, and so we've covered some of these methods already, and then there's some that we're aware of and some that we're going to look at. So we're going to look at the methods that we have kind of like seen before, so we'll kind of like build on those, and that's what we're going to that's what we're going to do in this particular session. So we're going to look at the clear, copy, pop, and update method, kind of like all in one go. Um, and that's only because we've got some familiarity. So I'm going to copy this piece of code up here, which is to make a dictionary, and paste it down here, because I believe that should be enough to start with. Let's make a dictionary and run it, and we get our dictionary, and our dictionary is a bunch of key value pairs. Here's one pair, here's the other pair, and here is the third pair, Charlie's 11. And then the next thing that we're going to do is we're going to try the clear function. So let's clear the dict, and we could even do something like, well, actually we'll just do d.clear, just like that. And when we hover over the function, and we see it already there, but the clear function returns, so there's a function here and it returns nothing back, it just clears the dictionary. So we've seen this kind of thing before, and we can actually just run it, or let's actually do print d. There we go, and we get back this empty dictionary. So we'll put a little print statement in there just so that it's nice. Print, and again something like, we can actually even copy this statement here. Let's clear the dict. Quotations, let's clear the dictionary, and this is a clear method basically, so we're using the clear method. So we run that and we get let's clear the dictionary, and what we get back is this empty pair of curly braces, and that means an empty dictionary. It doesn't mean an empty set. A dictionary is a set of items, but this is actually, so we're getting back an empty dictionary. And if we did the type of it, we'd see that it is of class dict. Now we do the next thing. So clear was very easy, we've done it before. It returns nothing, it clears the list in place. That's what it does. Let's add items back, otherwise we're going to be working with an empty dictionary anyway, so it kind of like suits us to do this in the example. Update over there, and we will do something like, we're going to try the update method, which is kind of like it's the last method in our little list there, but we're going to use that next because we want to put the items back. So we'll do something like d.update, open brackets, and we can see that it takes in this thing here, and we don't yet know what this thing is. And then but well, actually we do know what this thing is. This is actually a dictionary, so we're going to put dictionary items into there, and it's going to return us nothing back, so we don't need to assign anything equal to it. We are updating again the list in its place. So that's what, sorry, we're updating the dictionary in its place. So we've got this empty dictionary, and we want to put back, say for example, all of our items here. And we're actually going to need the curly braces as well. So we could put back just one item. So we could just do this and put Alice, who is 10, back, and then do another update and another update. Or we could put them all in one go. So we can do that, and we can print D, the dictionary, and we get back Alice, Bob, and Charlie, the three names with their 3 ages. So let's just put something like print over here. Let's add the items back, and that was the update statement over there. So when we run it, we've got let's add the items back, and now we've retrieved all of our items again over here. So I might even take no, I'll just leave it like that, that's fine. So the next part is we are going to actually we can also do this. We can also do this, and this is kind of like more, I'm going to put this more, it's more convenient, right? Which is we can add the items back with the keys. So let's do the print. This is what we're actually going to do. Let's add the items back, but this time we're going to use, instead of using the update method, we're going to use the keys method. So we're going to use the keys because this is actually done more commonly, and all we have to do, if we wanted to add another item, we could have done something like this. And I'm going to add a new item now. Obviously, we've got Alice, Bob, and Charlie. That's already there. But if we made a new item, so we can literally select them from this drop-down list as well. But we can make a new item just like this. So Darren, and I'll set Darren to be the value of 10. So Darren is 10 years old, and then we can print. And we'll print out our list again. Our dictionary. I'm calling a dictionary list. I shouldn't do that. We can print out our dictionary again, and we just see that we've added on Darren. So you can see that we could go through a loop of some kind if we wanted to. We could go through this loop if we wanted to, and sort of like add names in and put the values in a more convenient way, possibly than using the update method. Although the update method would work arguably equally as well. So you've got two options for adding things back into dictionaries. And then finally, so just to show what we've done the clear, we've done an update, and let's do, we haven't actually done a copy and a pop. So let's remove an item. So let's remove an item which is called popping. So we pop something out, and we'll do something like d.pop, and we just hover over it, and we see here that we get back an integer that comes back, or something that's going to come back at least. So it removes the specific key and return the corresponding value. So not necessarily, in our case, it's an integer because we've got integers, but it's going to return the corresponding value of the thing that is popped. So really, well, we can just try and remove Darren like this, and we could actually even just print it as is, but we're going to tidy this up a bit. So we can print D, and we see that our list is back down and Darren has been popped. But what we're actually going to do is we can do popped. We'll set it to a variable. Well, first of all, we'll set it to a variable because we know it returns something back. So it's quite nice to see possibly what we've popped out of there. So maybe in our print statement we can show what we have popped, and then we can do something like an F string, and we can say we removed Darren, who was, and then popped, years old. And we could run that. So instead of just popping the item, we can actually return the value of what was popped back, and that would be, we removed Darren, who was 10 years old. But just something a little bit extra, because we don't want to kind of like have a name here and have a name here which is repetitious. We tend not to want to do that type of thing in coding. We could set a new variable to, so person equals Darren in this case, and then in here we can call person. So we're just popping whichever name we selected. So we're selecting Darren, and over here we could turn that into as well person. So now we can pop whoever we like from the list. So here we've removed Darren, who was 10 years old, but we could have chosen one of the other names. So let's just remove Bob. So Bob, it works with everyone now. And we've removed Bob, who was 12 years old. So that's quite nice. We were able to pop an item as well. And actually there was one last method, which is a clear method, which is a copy method. So let's create a copy, and if we do d.copy, just like that, we get this thing called a shallow copy of D, which is basically just a copy of D. There is a difference between shallow copy and deep copies. Deep copies are recursive, shallow copies aren't. That's best left for another day. But shallow copy is effectively taking this piece of memory and moving it back to another place in memory. So d.copy, and when we hover over it, we see that it returns something back. So we need to assign this to a variable, the copy. So let's just say, I don't know, our dictionary D has now turned into dictionary E. Or maybe something that's named a bit more appropriately. We could call it, I don't know, names and ages, or classroom. Classroom. And then we could do print classroom, just like that. And also we should probably put a print statement here. So print, let's create a copy, and that is obviously the copy using the copy method, just like that. So when we run it, we then get let's create a copy, and we've got a copy. We've removed Bob from our list. We've replaced Bob with Darren, and then we've created a copy of the list, and we printed out the copy, which looks exactly the same as what it was copied from, which was this dictionary. I keep saying list. This dictionary. It was this dictionary less whoever we decided to remove. So that's what was there. And the thing about this is that this is a copy. So if we append the copy, so maybe we will do that, we are not going to append the new dictionary because it's in a different memory space. So we'll try and do that. Let's add one person to classroom, or we could add one person to the D dictionary, but we could add one person to the classroom dictionary. Either way, we're expecting them not to interfere with each other because they are now separate in memory spaces. So we could do classroom. So we could just do print, let's check that this is a copy, right? As opposed to pointing to the same part of the memory space. So we can do classroom, or let's check that this copy is in a different bit of memory. There we go. It's nice and clear. So we can do classroom. We can add an extra name. So we used the name Elsa before, so let's do that again. Elsa. So after D, we've got Elsa, and then we can say that Elsa is 12 years old, and we can print. And also, actually, let's add a different name to the D dictionary. So D, and then we'll add on Fiona equals 11 years old. And notice that Elsa is added to the classroom dictionary. That's the second dictionary. Fiona is added to the original dictionary. So the two dictionaries, if they are different, they will show different names at the end of them. So let's just do print, and then we can do something like quotations. We'll just show which dictionary is which. Classroom, and then you can type in classroom there. So that's our classroom one. And if we do print and then original, I could just call it original because that was our original one. Then we can do that was our original dictionary that has been modified by the names. And we should see that if we scroll down, just run it. There we go. We've got Elsa added to the classroom dictionary and Fiona added to the original dictionary. They are in two different parts of the memory. We could show this with the IDs, but we've already kind of like seen this with lists. We've seen it with sets as well. So don't need to, like, we could do it, but we're taking it as it's operating in exactly the same way, and that's how collections behave. And that was so we've gone over the clear method, the copy method, the pop method, and the update method, and we've seen that these are like common methods among collections, and they work for dictionaries in Python too. So that's it.